Hello and good morning. It is Friday, August 9th. We are quite a ways into building this little project of mine here. And just to review, I am building a application that's going to help me at my D&D table when my characters say, hey, what does this guy look like? And what's their name and all of that stuff. What's his personality like? And so on. I've got some stuff falling over off screen there. And I'm bad at ad-libbing, so I'm building an application to help me help ad-lib for me. So let's take a look at the screen share. Here we go. There's that, and we got a big empty screen because we've got no files open right now. And yesterday when we left off, we had created a database table, and we had started in on a few things on the code side. Now, before I dive into the database code itself, or rather the code that's going to connect to the database, I want to talk a little bit about the database structure here. If you're already familiar with SQL Server, you know that the default schema, or you know that database tables and objects and so on are split into, or can be split into, things called schema, which are just collections of the objects that you create in the database, be that tables, views, stored procedures, functions, etc. And SQL Server by default puts everything into the DBO schema, DB, database owner. Now, that's fine, and it's super convenient to just go with the defaults. I've learned to avoid doing that, especially in this new, I say new, but the trend has existed since, gosh, the early 2000s, where there's a movement to get out of having a giant database and a giant application where everything's tied together and everything like that, because now we can push things into smaller containers that contain smaller, discrete, more focused sections of our code. And I'm not necessarily talking about microservices. I don't even like discussing those. However, I do like talking about having our code and data partitioned off into logical groupings. Whether those logical groupings are actually physically separated is another matter. I don't know that it's necessarily a good idea to design things to be physically discrete from each other right from day one. That comes with a lot of complication and a lot of complexity, and it makes managing and hosting and integrating everything much, much more difficult. However, if we design our systems as components, and that includes the storage aspects of those systems, if we design them with logical boundaries around certain sections, then it makes it much, much easier for us to pull those sections out and into actually separate physical manifestations if we decide we need to. Let's say we've got one particular part of our application that's receiving a lot more traffic and is receiving so much traffic that it's slowing down the whole rest of the application. It would make sense to pull that piece out and put it into its own little area on our network and maybe set up some automatic scaling rules around it or whatever, so that as traffic comes in and that piece is getting used a lot more, we can make more copies of that one little piece, and that way the throughput for that piece stays nice and smooth, and it's no longer consuming all of the resources that the rest of the application needs. But we don't really need to do that until we know what's happening. The flip side to saying, yes, let's build a monolith up front because it's simpler, is that we have to design what goes on inside that monolith and inside its single data store in a way that keeps us from making mistakes in the future that make it much, much harder or perhaps even impossible for us to pull that apart later. And that's why I don't like just dumping everything into the DBO schema in SQL Server. Hey, Rev, good morning. Rev is like, oh, microservices? Yeah, I don't like talking about microservices. I'm a much bigger fan of the concept of service-oriented architecture. I think microservices have a lot of dogma around them, and even the attitude of microservices are better than monolith is not always necessarily true. Both design types come with the same kind of rust risks, where with a monolith, as it rusts, it gets a whole lot harder and more expensive to even make tiny changes. But with a microservice, you end up with a giant tangle of razor wire instead of a big block of granite that's hard to work with. And I'd much rather take a hammer to a big block of granite than have to very, very carefully snip apart a tangle of barbed wire. That doesn't sound like much fun at all. So what I do in SQL Server when I'm spinning up a brand new project, or when I'm looking at a large tangled up database, is I try to find the pieces that go together, or I try to identify the pieces that are going to go together, and I put those into their own database schemas. So for our NPC storage, I've created a schema called user data. I've also created a user called gh_user data, and it's got write access to that. My TDD admin, that's my replacement for the SA account. And I use that, as a matter of fact, that's what I'm logged into SQL Server Management Studio as right now, is TDD admin. That basically gives me God mode over the database, and that you always need an admin account. Now, when we get into the code, the component that's going to be interacting with the user data schema is going to be assigned an identity, and that identity is the only one that's going to be allowed to write to these tables. When I add some user info, like a user table and their permissions and profile information, preferences, etc., that information is going to go into a user's schema. And I probably won't even have foreign key constraints at the database level, because foreign key constraints are fine if you've got a monolithic database, but they cause serious problems later on down the road. I would much rather manage those relationships and the relationship integrity and such at the code level. Yes, it means writing a lot more C#, but it does keep our database much more performant because it doesn't have to do all those consistency checks. And it doesn't hide the logic for how our objects interact and relate to each other. And it sets us up for being able to do eventual consistency later when we need to, or if we need to. So userdata.npcs is the table. I do have a user ID on here. I'm going to hard code this to 1 right now because I don't even have a users table. And before I deploy this, I'm just going to truncate this table and reset all the identities and everything like that. It'll be pristine. So how do we talk to a SQL database from our C# code? Well, there used to be ADO, active data objects, back in the old pre-dotNet days, and then we got active data objects.net with the system.data.sql client and all that stuff, and evolutions happened and things changed, and now we have Entity Framework. And I remember getting onto a project when Entity Framework was still new, and I really, really, really didn't like it. I felt like it was always trying to do way too much, and I derisively called it Clippy for databases, and I don't feel like I was too far off the mark on it, if I'm being honest. So what we need to do with Entity Framework is we set up models, C# classes, POCOs, plain old CLR objects that represent the tables in our database. Now, I need this column list right here. Boop. So I'm going to grab this, and I'm going to put each one of these guys on its own line. Like so. And then I'm going to say Control function Alt. Nope. Control Alt. Here we go. Let's get rid of all these square braces. Come out to the end. Now, I used to have a little utility script, and it's since been lost to the sands of time, that I could point at a table and it would create a C# class from it. But, So let's do this. Public. Whoop. Int. And these three are strings. What am I doing? Here we go. Bool. Date, time. And these two are nullable. And then I'm going to grab get, set, and let's grab that, Control X. And cut that from there. Open up my NpcRowModel. We're going to leave that internal. Paste all that stuff in here. Now, this is our key, and it's got a database generated, and it's an identity field. Are any of those string fields nullable? They are not. Okay. So to keep the compiler happy, because if I don't do this, it's just going to complain at me and it's going to bother me, and it's just going to add to my compiler warnings. ctor and species name string.empty, location name equals string.empty, and character details equals string.empty. Now, nope, because these are internal, I'm not going to add comments to these, because that would be a silly waste of keystrokes. All right, so we've created our row model. Now we need to add it to our DB context. And we're also going to need to, and I never remember what's involved in setting up the DB context. There's another step I have to do here to make it do a thing. But first, I need to public IDB set of no. Okay, so IDB set no longer exists. We're just going to use a DB set NpcRowModel NPCs get and set. And I need to add a reference to that inner thing. Here we go. And there are some things that I need to override here because I don't use entity framework migrations. I have always been afraid of them. And I've never trusted them to not destroy my data. So there's a couple of things that I need to look up. Number one is DB context set up SQL Server connection with connection string. Connection string to code first DB context. Let's see here. Base constring. Excuse me. What year is this? Because there have been some changes made. Oh yeah, that's old school. DB context. EF core. Here we go. Got an error saying, okay, yeah, whatever. Okay, I do know that I need to set up context options. I'm not going to do this down in my program.cs. That's crazy. Folks context, return SQL Server, DB context connection, options extension. Okay. What year was this? That was 2018. It's changed a lot since then. EF core. (2024). DB context lifetime configuration and initialization. Here's a Microsoft Learn thing. DB context lifetime. During a business transaction, yeah. I'm not going to mess with that. Use SQL Server, okay. That's nice. I'm not going to mess with that. Simple DB context initialization. Protected override void on configuring. That's what I want to do. Over here you go. Protected. Protected override void on configuring. And I'm going to say private read-only string connection string connection equals connection, boop. And then I'm going to say options builder dot use SQL Server. I'm going to pass it the connection string. There we go. And I have to tell it to use the member level connection string. And that should be about all I need to do here. And DbContext factory necessarily. DbContext options, configuring the database provider, yeah. Okay, don't care about any of this. Provider options, context configuration, sensitive data logging, all of this stuff. Create a model, manage database schemas. I don't want create and drop APIs, absolutely not. Migrations, how to disable migrations. Okay, so that's all this stuff. Customize migration code. Okay, blah, blah, blah. Adding raw SQL, arbitrary changes, remove a migration, listing them. I don't care about any of this. And honestly, what I'm worried about may not be an issue anymore. Protected, override, void. On model creating, I don't care about any of that stuff. Okay, I'm not going to worry about what I was worried about. I remember in the old days of Entity Framework, there was this little snippet of code you could add to your DB context that would keep it from destroying your database every time it ran. And I think that's about all I need to do here. So here is the quote-unquote model of our database as it sits so far. All right, so now we can come out to our access provider, the NPCAccess SQL provider. Pardon me. And NPCAccess, because our DB contexts are disposable, and I'm going to declare this. Do I want to make the DB context module? Yes, I am going to make the DB context module level. Private DB, nope. NpcAccess DB context underscore CTX. And I'm not going to assign that. As a matter of fact, I'm going to make it nullable. Down in here, step 1, convert the public DTO into a storage model. Step 2, determine if it's an add or update. Step 3, do the thing. One of these days I'll remember which keys to use. Step 4, is return the ID. Okay. And I need to implement IDisposable. I'm going to do this right now before I forget. And we're going to use the dispose pattern. And I don't like having the disposed value. Normally, I like having all of my module level stuff up at the top of the class. But when it comes to disposed stuff, I prefer to keep it all separate. And I'll even go so far as to region IDisposable implementation. And then down here at the bottom of our IDisposable and region IDisposable. And there is a really, really nice package of stupid Visual Studio tricks called ReSharper out there that you used to be able to set it up so that it would automatically wrap interface implementation methods in a region like that. But ReSharper costs a lot of money per year, and I don't want to spend it, so I'll just do this manually. So CTX, if not null, dispose. Now the reason I promoted this to module level is because in the course of some data operation, I might need to perform multiple operations against the same context, and I don't want to be passing that context into all of the different methods that are going to do these things. Excuse me. Although I may rethink this idea as I go, and if I do, I'll just refactor it out. I don't have any unmanaged resources, and there won't be any large fields, so I'm going to get rid of these to-dos right now. Clean up those extra line breaks. Has code to free unmanaged resources, and we don't. Goodbye. And all right, good. That's all set up. Let's hide it. Goodbye. All right, so save NPC. Now, because we're going to be doing a lot of translation between the public DTO type and the inner storage types, and we're going to be going back and forth, I am going to create, we can hide the context details right now. I'm going to add a new folder. A transformers namespace. And I'm going to add a new class called model extensions. We're going to make it static because these methods are only to be used inside the SQL Server implementation of NPCAccess, because they're translating between the public DTO declaration and why is my camera way the heck over there? That's a crazy place for it. That was very silly. So we've got our public DTOs here. We've got our models here, our storage models that mirror the table structures over here. And I don't want these table structures to get leaked out into the rest of my application. So all of these translation extension methods are going to live internally to the SQL Server implementation because they really are only relevant to these exact table models. So public static, and I'm not typing, public static, and let's do the NpcRowModel to row model. And we're going to take a, what are you called? NPCAccess model. NPCAccess model. And I'm going to call that variable DTO. And I'm going to set up another one right now. Public static, because we're going to need it soon. We don't need it right now, but we're going to need it soon. NPCAccess model to DTO, NpcRowModel, row model. Okay. NpcRowModel model equals a new one of those. And we're going to return it. We'll do this right now so I don't forget. Model dot NpcID equals DTO dot NpcID dot get value or default. Model dot user ID equals DTO dot user ID. Model dot is public equals DTO dot is public. Model dot species name equals DTO dot species. Model dot background character details. Oh yeah, that's right. Background isn't a public property on this. Vocation. Model dot character details equals DTO dot character details. Now I want to talk a little bit about why I'm storing species name and vocation name, but not the background or really anything else on this particular table. Or rather, I've made species and vocation public, but not the background or any of the other details as discrete columns on this table. And that's because I anticipate that we'll be in the user interface wanting to search our list of pre-created characters based on their profession and their species. I might add name eventually, but I'm probably not going to do that today or even in the near term. Character details is going to be the JSON serialization of everything, that all of the assigned properties that have been set so far. Now we've got some date fields. And the values that get assigned to those date fields depend on whether this is a new NPC or an updated NPC. So what we're going to do is if DTO dot NpcID dot has value and no, get value or default is greater than 0. Get value or default is a method. Existing NPC, it's an update. Else new NPC, it's a create add. And I can't actually do this stuff here, I don't think. Because this is just a straight up transformation. And in order to set those properly, I actually need an instance if it's an existing NPC. I need the instance of the database model. All right. Not going to touch the model date props. We'll do that in the actual method that is writing the NPC. Let's implement this now. NpcAccess model DTO equals new NpcAccess model return DTO. Rename this from RowModel to just model. DTO dot NpcID equals model dot NpcID, DTO dot user ID, model dot user ID, DTO dot species equals model dot species name, DTO dot character details, let's map that, DTO dot vocation. Oh, stop that. Drop table operation. Absolutely not. DTO equals model dot vocation name. And I believe that's all we need to send. Yep, that is it. Pardon me. 2DTO, NpcRowModel model, yeah. All the things, all the stuff. Good. That's all we need for these extension methods for now. Let's get rid of all those usings because we don't need them. Bonk. NpcAccess model. Okay, good. I'm surprised it's not complaining about that because it ripped the using out of there. Oh. implicit usings enabled. Yuck. Disable that. I forgot to turn that off. Gross. I bet that's going to break stuff now. Build solution. Here's my errors. That's fine. Yeah, okay. That's easy enough to fix. Transformers. I'm really surprised that it's not complaining about that yet. I'm sure it will. Let's come out here and fix this stuff. INpcAccess. Using system. And probably need to come out here and go using game tools dot NPCAccess. Bam. Remove and sort. Boop. Oh, what are you complaining about? Why is this being silly? Go ahead and implement the damn interface. And I bet it got stuffed in here because Visual Studio is sometimes silly. Yep, sure is. Control X. Run up here. Control V. Oh, I didn't want to implement it explicitly. Public. There's no difference. None. Now, is it back to complaining about that? Nope. Okay, I guess it just got silly. All right. Not all code paths return a value. Yeah, I know. First thing I got to do. NpcRowModel equals npc dot to row model. Doesn't like that because it can't see it yet. Excuse me. Using game tools dot NpcAccess dot SQL Server dot transformers. Save. You still complaining? Yep. Save all, build, rebuild. Visual Studio's in a state today. It's being petulant. I really don't want to make model extensions public. Let's see if that fixes it. I know I've used this in the past. What are you complaining about? NpcRowModel is left. Yes, I know. Internal. Save. Access model does not contain a definition for to-row model. Because I have brain damage. I'm only on my second cup of coffee. Build. So that fixes that. Good. We're back to normal. So we've got our row model. CTX equals CTX, but if it's null, new with the connection string, user data CN. CN. And because that is not public, I need to make it public here. And I'll call the base class constructor, come back out here, and that's been resolved. Good. Now this I don't love. Don't like it at all. Because I'm going to have to write that every darn time. Private NpcAccessDbContext, capital CTX, get. I'm going to make a private property that's going to mask this nonsense. Okay, so NpcModel dot, no, NpcRowModel existing equals CTX dot NPCs dot first, or no, I can use find async I don't know if I like that, but npc dot npcid. And we're going to await it. Okay. if existing is null, add what? Set the metadata for a new NPC and add it to the context. Else, apply the incoming changes, update the context. Save changes, async, go home, await that guy. And we don't actually need to do that translation. That's wasted cycles. Get rid of that comment. Get rid of this comment. We're going to rename this to model. Return model.NPCID. We'll deal with that null reference risk in a minute. So if model is null, model equals npc.toRowModel. Model.createdDate equals .now. Save this. Model.updated equals datetime.now. And I remember running into issues. We're going to have, when we get into debugging this thing, I remember running into issues with datetime .NET types versus SQL datetime, the plethora of SQL datetime types. It gets really, really wacky. But we're going to need a new extension method. And what we're going to do is public static NpcRowModel apply application changes. This NpcRowModel model, NPCAccess model, DTO. And I'm going to change that from apply application changes to apply inbound. Here's where we update the model instance with whatever came in from the application. We're only going to update the user manageable properties. And those are model.isPublic equals DTO.isPublic model.speciesName equals DTO.speciesName, just species because the DTO doesn't use species name. Model.vocation name equals DTO.vocation. Model.character details equals DTO.character details. Return the model. Back to our access class. Model equals model dot apply inbound changes from the DTO. What did I call it? NPC. NPC. And then we await the save changes async. Oh, I probably need to ctx.update There we go. And down here, I got to go ctx.add model. Save changes. Is update and add asyncable? I doubt it. No. Because they're just doing in-memory things. The actual connection or writing to the database happens out here. Now this is all fine and dandy. And I don't think I'm gonna log anything. Or throw an exception. Except for the fact that exceptions happen with SQL and database and external services all the darn time. So this afternoon, before we integrate this with the manager, we are going to, what's this class 1 up here? That needs to go away. Get lost. Go on. Go on, get. All right, so in here, to do, instead of a task of int, create a new class that can wrap an exception method or an exception message and the expected value type for an operation return a task of that thing. Instead, that means we can catch, log, wrap, and return the exception without throwing. Woot. And dev leader Nick Cosentino has a number of really great videos about what happens when we abuse exceptions in .NET, and when we throw exceptions around our application, it does horrible things to our performance, like several orders of magnitude of processing cost, and not to mention memory, stack, all of that stuff. And when we're building for the cloud, we want to make sure our code is as lean as possible. Because when we're hosting in the cloud, we're paying by basically bits per second, like memory cost, like how many seconds are we consuming a gigabyte of RAM, or a gigabit of memory, and how much processor and everything like that. And if we don't have to focus on it, like we don't have to beat ourselves to death about performance issues. But if we know some things that definitely blow up the resource consumption for our application, why don't we avoid those up front? I don't believe that this counts as pre-optimization. So when we come back this afternoon, I'm going to create just a really simple little wrapper around our return value that can optionally carry an exception or an error message back to the caller rather than having to throw exceptions. And then we'll wrap this in a try-catch. This whole shebang will get wrapped up in a try-catch. We'll add a little bit of logging, and then we'll set up our dependency helper, which I stubbed out yesterday. Right now it's empty. And then we'll start integrating down to the manager and all the way out down to our client. So until 1 o'clock this afternoon, take care of yourselves. Go get some tasty lunch, drink some water, maybe go get some sunshine for a minute or two. By all means, please step away from your desks. And I'll see you again this afternoon. Take care.